Hello friends, welcome to our channel. Let's have a look at problem 3434, maximum frequency after subarray operation. This is a very interesting problem. So in this video, we're going to demonstrate how to use dictionaries to help us solve the problem. Actually, this problem have a certain flavor of Candine's algorithm. Let's first quickly look at the problem statement. Then we can digest with one example. So here we are given an array called nums of length n. So also we are given an integer k. So we can perform the following operation on nums once. So we select a subarray between index I and j, both inclusive. Then we can add an integer x to add to all the elements. So we want to find the maximum frequency of the value k after this operation. So needless to say, we want to add we need to add a certain amount with the most frequency element in between I and j, so that we have as many keys as possible. But also we need to notice that in between I and j, there might be some indices with values k. In this case, if we do this operation, we also decremented some integer keys. So in this case, we need to make precise or accurate counting. So that's, I guess, the main point for this problem. So here there are several examples. So if you look at example 1, so because k is 1, right? So then all the other elements have frequency 1. You just change 1, right? You change 1, so you get for example, I add negative 1 to this 2. So then we are going to get 1, 1. That's 2 1s. Of course, you can also add to some other integers that's the same, due to their frequencies are the same. So if you look at example 2, actually, this one, k is 10, right? So then you see the remaining ones, you have 3 2s. Obviously, we can add 8 to all the numbers between this 2 and this 2. Then the 2s will turn to be 10, right? So you have 3 2s, so you have 3 10s. So together, 1 plus 3, that is 4. So that's the 2 examples. Here we have the constraints, right? Length is at most 10 to the power 15. So this is the one. And also, we notice that nums I is in between 1 and 50. In other words, it at most 51 possible numbers, right? So k is also in this range. So with that said, let's look at the analysis. So in order to do this problem, we need 2 pieces of information, essentially. First is that for each number y, we need to get its frequency, right? And its start and end indices. So this can be treated using dictionary for sure. And for any closed interval ij, so if we want to change all the odd numbers to be the k, so then if there are some k's in between, then those k's are decremented or disappeared. So we need to know the occurrences of k's within this closed interval. So how do we get this? So we can use prefix sum, right? So this you can use list or you can use dictionary. This is also very straightforward. So once we have the above 2 pieces of information, then a solution is almost there. But I guess there's a subtle point. So I want to point to you using this example. So here k is 4, right? 4 appears here. And then we have some other integers. Like if you look at 2 appears 3 times, right? So if you change all the 2s to be 4, in other words, the shaded area, you're going to add 2. Then this 2 4s actually becomes 6. The 3 2s becomes 4. Then this way you get 3 4s. But 3 4s is not the final answer. The reason is that I can choose the last 3 elements and then add 2 to all of them. Then the 2 2s becomes 4. Then this 2 4s plus original 2 4s, you get overall 4 of the 4s or the keys. So that's the point. So in other words, though we know the beginning and ending index for the 2, it's not necessary to change starting from the first occurrence of 2 to the last occurrence, we can change a part, right? For example, in this example, we change this 2. So this is actually a crucial point. If you realize this point, I guess in large extent, you can get the logically correct solution. So with that said, let's look at the coding. For the coding, we have 2 purposes. First, I want to explain how to use dictionaries. Second, we want to explain the problem logic. Let me first, so here, let me make some comments. So one pass shall be enough. For this problem. But here, I will first write a 2-pass solution for pedagogical purpose, and then I'm going to slightly improve it to be a 1-pass solution. So let's look at the first one. So first, I'm going to get the length of this nums. So this is nothing but just for convenience. Then I also want to get the original number of keys. So nums count the key, right? So this is very straightforward. So starts. So I'm going to use collections default dict. So I'm going to map everything to be -1 at the start. So that's going to store for each number the start index, right? So this actually is not identically the original start. So we are going to change it. This is a dynamical thing. You should keep this in mind. So ends, I'm also going to use the same thing. Collections default dict lambda. So I'm going to map everything again to -1. So here you can choose -1, or you can choose some any numbers or none. But let's use -1 here. So you need to make this consistent with your logic. So here also I want to get prefix count of keys. So here I'm going to use collections default dict. So I'm going to map everything to be 0. So this is very natural. So basically, prefix count given an index. It means that the number of keys from the start up to this index, both inclusive, right? So the number of keys in this range from index 0 to this index. And also I want to get the frequencies of the integers. Collections default dict. So here we should map everything to be 0. This is also natural, right? If you look at the start, you can end. So the initialization or the mapping are different. So then I want to see if I use the operations here, how many new keys I can get. Let me first do this. Let's first fix this prefix count. So this is basically for iy in enumerate nums, and then prefix count. So at this index, it should be incremented by prefix count I minus 1, right? So then we just need to check if the current number equals key or not, right? So this is very natural. So next we are going to do this thing. So we are going to use the result. So here the result is the new or extra keys we can get. So once we get the maximum extra keys we can get, we just need to return keys, original keys plus the result. So now let's iterate over the list to get this piece of information. So basically for I, y in enumerate nums, and then if y equals k, so actually we don't need to consider it because we don't change this y's, but you can choose to use it. It does not matter. But logically, let's first distinguish these two, right? So now let's add the frequencies of y is incremented by 1, right? And then what we want to see is that if starts of y, so if this is the first time we meet this y, in other words, the value is the default value -1. So we're going to set frequencies, frequencies. Starts y equals I. So when we see a new frequency, a new y, so the nearest ends is always the current index, right? So then we get this one. So now what we want to do is that we want to see if we change the numbers of y to be key within this start and end. So how many keys we can gain, right? So this net equals, so frequency is y, right? Minus, so how many y's. So we want to change all these y's to be key. You can see this is a new case, but we need to minus the keys in between the start and end, right? So this is actually very easy to compute now. Prefix count, so ends of y. So minus prefix count, so starts and y. Because we need to include the start of y, so we need to use this -1, right? But here I'm using a so here I'm using a default dictionary. If this is 0, right, so you have -1, it does not matter because this will be 0, right? So in other words, this is always right. So once we have this one, so we're going to check if net is greater than 0. In other words, indeed we have some extra keys. So what we get is the result will be the max of this net. So otherwise, so if we do this change, actually we don't gain extra keys. So in this case, we're going to set starts y to be I and frequencies y to be 1. In other words, we don't consider this previous start and end interval anymore because it does not do any good in our task. So then what we want to do, so after this one, we just need to return result plus the keys. So that's actually the full code. Let me first do a test. It passes the 2 cases because I feel that these 2 examples does not cover the general case. So especially it might be good to look at this one. So now let's look at the general case. Yeah, it passes all the cases. So now let's make some comments. So notice here that, so if we look at this second for loop, so when we do this, so the end is at most I. In other words, if we look at this current I, we don't need to know the prefix counting after index I. In other words, we can combine these 2 for loops. Let me copy this part and make some changes. I'm going to change this one to be version v1. So this actually I scanned the toolpath, right? I scanned the nums twice, but this is just for pedagogical purpose. So now let's look at here. So we have this one, but then I'm going to do this. Delete this one. And then what I'm going to do, I'm going to introduce again, right? So how many extra keys I can get. So then what I'm going to do is like this. Because each time the start and end is at most at this one, right? So we can determine the prefix count in the process, and meanwhile we do these operations. So now let's check, right? So this should not change. So we get this night. So here we are going to change this to be again and again, right? The same thing. So here we just need to add the again and the keys. Let me first run through it, and then I'm going to explain one more thing. Let's submit directly. Yeah, it passes all the cases. So now here, you can choose to use this, add these 2 lines or not, because if it were a key, you can still do the things below. It does not matter. But in principle, we can distinguish this. So if I comment this out, so I submit, it still works. But I hope that I would like the logic to be crystal clear, so I can just add those. Yeah. So with that said, I guess that's the comment on this one, and also on the one pass or two pass thing. So another thing I guess it worth mention is that you can look at this condense algorithm. So this condense algorithm is essentially a dynamic programming algorithm. Basically, it solves such problem. You're given a list, right? So find the largest subarray sum. So among all the possible subarrays of the list, of the given list. So if you can think deeper about this algorithm and the problem here, that would be also interesting. So here I would see it's good to use the second way, one pass, right? And then it's also good to understand the details here. So another thing, this is the repetition maybe. So you need to look at this example. So with that said, I guess that's about it for the current problem. Thank you for